Hi Math 2, this is Unit 7, Lesson 2 about inscribed angles. And our first diagram in 2.1 is showing us a picture of an inscribed angle. Its vertex D is on the circle. So an inscribed angle has its vertex on the circle. So you'll notice that unlike a central angle, the vertex is not on the center, the vertex is on the circle. And this creates a relationship where the inscribed angle is equal to half of its arc. So in this case, let's say this arc BC is 60 degrees. So the measure of arc BC is 60 degrees. Then my angle D, the measure of my angle BDC that you see right here would be 30 degrees. The inscribed angle is equal to half of its intercepted arc. So let's take a look at another example from yesterday of a central angle. So this picture is a central angle. This angle has its vertex on the center. So as a reminder, a central angle has its vertex on the center. And we learned in our last lesson that it's equal to its arc. So a central angle is equal to its arc. So in this case, if this was, let's say, 85 degrees, so the measure of CQ, arc CQ is 85 degrees, then the measure of my angle CAQ would also be 85 degrees because this is a central angle. And so these are now two different types of angles, inscribed angles and central angles. Since we're at home, then we won't be doing this bottom part. If you happen to have a protractor, you're welcome to measure. You will get different numbers than I used in class. Those were approximations based on the way it looked. So let's take a look at the next page. So on the next page, it says, right here where it's, I think I put a mark on my page. I'm just getting used to this. Sorry about that. So on this page, I'd like you to cross out 3 and cross out 4 for a moment. And we're just going to put a few examples of inscribed angles here. So let's do an inscribed angle. The first example, example 1. We're going to do an inscribed angle where we know the arc. So in this picture, I'd like you to label this A, B, and C. And in this one, I'd like you to give the arc a measure. Let's say this arc is 50 degrees. And example 2, let's draw a similar picture, but let's make our angle more obtuse. So we'll have a wider looking angle right here. And let's call it D, E, and F. And this time, let's give the angle a measure. So we're going to say that this angle that we see right here is 120 degrees. And example 3, we'll do together in just a moment. So let's go back to the first two. So in the first one, if the arc AC is 50 degrees, I'd like for you to find me the measure of angle ABC, my inscribed angle, this little angle that you see right here. And in this one, if the measure of my angle DEF, my inscribed angle is 120, I'd like you to find the measure of the arc DF. So let's go back to this one. Did you say that the measure of ABC was 25 degrees? Because remember, from the previous page, an inscribed angle is equal to half of its arc. So I divided the 50 by 2 to come up with my angle measure. And in this particular example, my arc from D all the way over to F, my arc would be equal to twice my angle, or 240 degrees. So my angle is equal to half of my arc. So I know that my arc must have been 240, and over here I know that my angle is equal to 25. So that brings me to another type of drawing, kind of similar to the one you're looking at in the Are You Ready for More? In this case, I want to make almost a Pac-Man looking diagram. So start with, on this side, call this G, and then on this side have an H and have an I, and put the center of your circle in here and we'll call it J. So now I'd like you to connect H, J, and I, creating a central angle. Next, I'd like you to connect H, G, and I, creating an inscribed angle. It creates almost this Pac-Man looking shape, and I'll write in a different color. So I can give you any of the three measurements. I could give you the arc HI. So let's say that the measure of arc HI equals 70 degrees. So the angle measure of my central angle and the angle measure of my inscribed angle, I can now figure out based on knowing my arc is 70 degrees. So what would the measure of angle HJI, that's my central angle, and then the measure of angle HGI, that's my inscribed angle. What would those be? Hopefully you're thinking that your central angle is 70, because remember the central angle is equal to its arc. And so the inscribed angle then would be 35, because the inscribed angle is equal to half of its intercepted arc. So let's take a look at the next page. So this is page 163 in our book. And on page 163, we're going to be talking about having multiple inscribed angles. So if I could redraw this circle with only the blue arc CE, so put C on your picture and E on your picture, and then also put D and also put B. And in this case, connect E to D and to C. So here is one inscribed angle to CE. So this is my arc CE, and one inscribed angle is D. Now connect C to B and E to B. You can now see that there is a second inscribed angle in my picture, and that would be angle B. So up here in this picture, we're going to see multiple inscribed angles, and that was just detailing one of them. So let's take a look at this problem. It says that from C to E is 100. So I know that this is 100 degrees. It says the highlighted arc from D to B is 140. So I know my yellow arc is 140 degrees. It says to prove that the triangles CFD, so that's this triangle on the left, CFD, and the triangle on the right are similar. So remember, similar triangles can be proved by several ways. One of them was the angle similarity postulate, which is where I'm going to be going with this. So first of all, I know that D is 50 degrees because CE is its intercepted arc and it's 100. So I know that my inscribed angle is half of that. I also know that B is 50 degrees for the same reason. The arc for angle B is also CE, so it would be half of 100 or 50. So now let me get a different color and let's take a look at C. So angle C, if I follow the sides of the angle, it intercepts my yellow arc, which is 140 degrees. So this is 70 degrees, half of 140. For the same reason, E is also 70 degrees. And then just going back, I do know that the angle on both sides of F is congruent because they're vertical angles. So in this picture, I've now shown that triangle CFD is similar. Oh, I'm drawing the wrong shape there. Let me just erase that. CFD is similar to triangle EFB by the angle similarity postulate from a long time ago, I think Unit 4. So this is a picture that had multiple inscribed angles that I had to evaluate. So let's take a look at our summary down below. So in this picture, this again is the one that we used on the previous page, the picture that we talked about looking a little bit like a Pac-Man. I have an arc, a central angle, and an inscribed angle. So let's say we know that the central angle is 50 degrees. So the measure of angle AOB equals 50 degrees. Well, then I can figure out the measure of my arc AB from that. And I can also figure out the measure of my inscribed angle ACB. So pause for a moment and think about what those answers would be. Hopefully for arc AB, we're thinking 50 degrees. And for the measure of ABC, we're thinking 25 degrees, half of 50. My inscribed angle is half of my intercepted arc. And it doesn't matter where C is. Wherever I place C, if I connect that point to the endpoints of A and B, I'll have an inscribed angle, which would be 25 degrees. Thank you very much.